Hey Opties! Today we're on Khan Academy looking at simplify rational expressions, common binomial factors. So this is going to be more of factoring to solve instead of just GCF factoring, maybe some using our Punnett square factoring or just factoring our trinomial. So let's go ahead and take a look. Okay, number one says simplify the following rational expression, and we've got trinomial as the numerator and the denominator. So we do want to look for GCF to start out, and we always try to do that. And we do have a GCF of 5 for our numerator, which is great because that makes our numerator be a trinomial of a equals 1. So our k squared coefficient is going to be 1 when we factor out our 5, which is great. So let's go ahead and rewrite that with our 5 factored out in the numerator. So 5, and then we have k squared minus 10k plus 9. That's our what's left over, and of course we still have that same denominator. Okay, so let's look at our trinomials and factor those if we can. So we're still going to have our 5, and we want to break this down into 2 binomials and break down our denominator into 2 binomials. Okay, k squared minus 10k plus 9. So factors of 9 that add to negative 10. That's going to be negative 9 and negative 1. It's a pretty nice one to factor. That wasn't too bad. And let's look at our denominator. Factors of 81 that add to negative 18. That's negative 9 and negative 9. Okay, notice that we are going to have a common binomial factor being k minus 9. Those do simplify to 1. Our final simplified version is 5 times k minus 1 divided by k minus 9. And we don't have to put the k minus 9 in parentheses because it's not with any other factor. So let's go ahead and write our simplified version here. And I'm going to go ahead and get a denominator. And I like to try to start my writing with a fraction bar. Otherwise, you see what just happened and it gets kind of look crazy. So 5 times k minus 1. Yes, you better put a k. I'm pretty sure if you put an x whenever the question gives you k, it will count it wrong. So make sure you're looking at the variable it gives you. Okay, so now we want to figure out what values of k make the expression undefined. Okay, remember, restrictions or numbers that make your expression undefined count for the original and the simplified. So we can look right here at our middle step of k minus 9 and k minus 9. And actually, since these are both the same thing, we only have one answer, but if they were different, we would have 2 answers. So it's going to be positive 9, k minus 9 equaling 0, gives us k equals 9, and of course we know that k cannot equal 9, but the thing that makes it undefined is k equal to 9. So let's check, and we're good. Next question. Notice our denominator is out of order in terms of being in true standard form of our quadratic. We'll probably want to fix that. And we're going to try to see if the z squared minus 196 is a difference of squares, because it is one term minus another term. So we're going to test that. So we have to check to see if 196 is a perfect square. And we definitely want to check to see if 14 is a factor of all 3 of these crazy numbers in our denominator, because we would really not like to deal with 1,372 as our c. So let's try to fix those things. So using my calculator just to double check, the square root of 196 is 14. Of course, it's plus or minus 14. But we know it's a perfect square. So we are going to be able to factor our numerator with the difference of squares method, which is great. Let's see if 14 is a factor of all 3 of our coefficients, a, b, and c of our denominator. Okay, so I figured out that if you divide each of these numbers by 14, you get nice numbers, so aka whole numbers. So 14 is a factor of all 3 of these numbers. So let's go ahead and simplify. We can go ahead and factor our numerator. It's going to be z plus 14 times z minus 14. Okay, in our denominator, we're going to have z squared, or actually it's negative z squared, plus 7z plus 98. And I just used calculator to figure out those numbers. Okay, so we really don't like the idea of having a negative on our z squared. So we can get rid of that if we just put our negative up top. So if we put it up top and call that a plus, it works. But we have to change the sign of everything to make it work, because we just removed the negative from the whole entire denominator. So now we're going to factor z squared minus 7z minus 98. So we have to find factors of 98 or negative 98 that add to negative 7. 98 divided by 7 is 14. So we have negative 14 and positive 7 for our denominator. So I'll just write that below here. Let's see, plus 7. Okay, so that's our denominator. Let's write it all together because it's looking a bit crazy, I know. Negative z plus 14 times z minus 14 over z plus 7. And I know I'm changing the order, but I want to do that. So our common binomial factor is vertically aligned. So z minus 14 is our last factor of our denominator. And those simplify to 1, z minus 14. So our simplified version, again, start with that fraction, makes typing it in a lot easier. I'm going to go ahead and distribute my negative here. So it's going to be negative z minus 14. And the denominator is z plus 7. Okay, so let's finish off by what are the values of z that make the expression undefined. Remember, that goes for the original. So we did factor out a 14, but 14 cannot equal 0, so that doesn't matter to find our restrictions. So what makes both of these, the z minus 14 and the z plus 7, equals 0? That's, of course, positive 14 and negative 7. So positive 14, negative 7. Let's check. Okay, I realized what I did wrong. We did not, I can't believe y'all let me do this. I'm just kidding. Obviously, you're not here with me right now. We forgot, or I forgot, to put the 14 on part of the factor of our denominator. So we really have that 14 still here. Super sorry I forgot that. Still here. See, it's good that I made that mistake so y'all can see, because that is a very common mistake. So now that we've got that in parentheses, let's put our 14 there. Okay. And we're good. See, do not forget your GCF that you factor out. All right, Opties. That's really great that you saw my mistake. Hopefully you won't make the same. And that's it for Simplify Rational Expressions Common Binomial Factors. See you next time.